Alright, here's the review for your study guide. Number 1, in probability, a sample space is the set of all possible outcomes. Number 2, the outcome of one event does not rely on the other event. The events are independent. The intersection of two or more events is all of the outcomes shared by both events, and is denoted by the word "and" or with the symbol, the intersection symbol. Any subset from a sample space is an event. If the outcome of one event relies on the other event, the events are dependent. The union of two or more events is all the outcomes for either event is denoted by the word or the symbol. The complement of an event is a set of outcomes in the sample space that are not included in the outcomes of the event. It is denoted by the word not or with the symbol prime with a comma, or you may also see it with a bar. Two events are mutually exclusive if the events cannot occur at the same time. Conditional probabilities are found when one event has already occurred and the second event is being analyzed. It is denoted with probability of A given B. Probability is A given B. Alright, we're going to draw these. A union B is the shading of A and B. A intersect B is shaded in the middle of the intersection, or A and B. A complements everything that is not in A. Mutually exclusive events, A or B, probably A or B, A plus B. Overlapping events, D, probability of A plus probability of B minus probability of A intersect B. Conditional probability, given probability of A given B, the intersection over probability of the intersection of A and B over the probability of B. Independent events, probability of A and B, or the probability of A intersect B is equal to the probability of A and the probability of B. Number 1, use a table to determine the probability of selecting a card that is a heart, given that the card is a face card. Alright, so A is probably of a heart, and B is probably of a face card, probably of A given B, a heart given that is a face card. Use our formula for conditional probability. Probability of A intersect B over the probability of B. Probability of A intersect B is 3 over 52. The probability of just B is going to be the face card. It's going to be 12 over 52. And then we put them over each other. We cancel out the 52s, and we get 3/12, which is 1/4. Miss Nolan's class, there are 12 boys and 16 girls. On Monday, 4 boys and 5 girls were wearing white shirts. What is the probability of choosing a boy or a student wearing a white shirt? We know or means that we're going to union B. So A is probability of a boy and B is the probability of a white shirt. And then denoted by probability of A union B. So we're going to make our Venn diagram here. We know we got 12 boys, but 4 of those boys have white shirts. So we put 4 in the middle, and we subtracted 12 minus 4 to get 8. Here we subtracted 9 minus 4 to get 5. And then we have 11 left because we have 11 girls that are not included because we have 5 girls that wear white shirts, white t-shirts, and so 11 of those are on our universal set. So we know we have a total of 28 because 12 boys plus 16 girls is 28. We add these together. 8 plus 4 plus 5 gives me 17 over 28. Number 3, I made my sample space here. Probability of A is prime numbers. Probability of B is one of the numbers is a 3. So we got the probability of A given B. So right here, we know the intersection. So all of our ones that have a 3 in it and make a prime number are 2, 3, 3, 2, 3, 4, out of a total of alright, so we know we got probably A intersect B here. It's going to be 4 out of a total of 36 and a total number of outcomes. And then the probability of just B is going to be 11 because we count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Out of 36, cancel out the 36s, and we get 4 out of 11. Here's the probability of rolling a prime number, and given that one of the rolls is a 3. Alright, Mr. McKinney surveyed 240 men and 285 women about their vehicles. Of those 155 men and 70 women said that they own a red vehicle. Person is chosen at random from the survey. What is the probability of choosing a woman, or, which is union? Person that does not own a vehicle. Now, you can write this a couple different ways. Probability of A is probability of choosing a woman, and probability of B is does not own a red car. Now we got to fill out our frequency table first. I got men and women, and I know that's a total of 285, and for women 240 for men. I also know that 155 own a red car and 70 do not, so all I do is subtract 70 from 285, I get 215. I subtract 240 and 155 and I get 85. I add those up. 155 plus 70 is 225, 85 plus 215 is 300, 240 plus 285 is 525, and then 225 plus 300 is 525 as well. Now, my notation here, and I need to add something to my notation. So, A union B, right here, minus A intersect B, because we're going to add one extra, you'll see. So the probability of a woman, so we know that is 285. And then we got probability of B, which does not own a red car, 300. Notice we use 215 twice. So we do 285 over 525 our total, plus 300 over 525 our total, and subtract 215 because that's what number we've added twice to get both 285 and 300, and you get 370 over 525 reduces to 74 over 105. Or you could just add up 70, 215, and 85, and you get 370. Alright. Next one, Nyquist spins 2 spinners that have 4 equal sections numbered 1 through 4. If he spins a 4 on at least one spin, what is the probability that the sum of the 2 spins is an odd number? Alright, so if he spins a 4 on at least one of the spins, What is the probability that the sum of the two spins will be an odd number? Finish our set here. We know we got 4 and 1, 4 and 3, 3 and 4, and 1 and 4. So that's 4 out of a total of 16, because you know we got 4 columns and 4 rows. 4 times 4 is 16 for our total, and that gives us 4 over 16, which is 1 over 4. The sum of an odd number, so we're intersecting these two. So where does the sum of an odd number and spinning 4 intersect? It'd be A intersect B here, which would be 1/4. 6, in Cedartown, the probability that a person plays sports is 65%. The probability that a person is between the ages of 12 and 18 is 40%. So these two are event A and event B. Person plays sports, event A. Person that is between the ages of 12 and 18. Our intersection of these is a person that plays sports and is between the age of 18 is 25%. So now the intersection here is going to be 25%. We know that A and B, our intersection here, should be the same as the probability of A times the probability of B. So we know that's 25%, so I'm going to multiply 0.65, which is our A, and times 0.4, which is our B, which gives me 0.26. They are not equal to each other, so they are not independent. Now they're pretty doggone close, so they're pretty close to independent. Technically they're not because of the formula. Alright, a random survey was conducted to gather information about the age of employee status. The table shows the data that were collected. So right here I went ahead and did my totals. Always when you get frequency table, go ahead and add up and find your totals here. Alright, so I end up with 944 for my total here for the whole thing, 607, 337, 679, 265. Then A is the probability, so right here it says given, so we know we're using given. What is the probability of random selecting a person surveyed has a job? So probability has a job, so we know has a job is our A, and probability of B is less than 18, so this is our B. That's our given here, so we got probability of A intersect B over probability of B for our formula. So we know right here the intersection of these two. So we got A right here, and we know we got B right here. Now they intersect right here at 20, so that's 20 over our total of 944. And the probability of just B, which is less than 18, which is 265 over 944. We cross out our denominators because when you multiply by the reciprocal, they're the same. 20 over 265, which simplifies to 4 over 53. Alright, that's it.